Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 130, I chat with Steve Venuti, the president of HDMI Licensing, about the ins and outs of HDMI. So stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded October 1st, 2012. Episode 130, HDMI from the Inside Out. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, the Home Theater Geek. This week's guest geek is Steve Venuti, the president of HDMI Licensing, the organization that actually licenses HDMI to manufacturers who want to use it, which is just about everybody. Hey, Steve, welcome to the show.
Hi, how you doing, Scott? Thanks for having me.
I'm doing great, thanks. Thanks so much for being here. Those who are watching live at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Steve, and I'll pass along as many as I can. So, let us start with a little bit of the history of HDMI. When did we first see it? How has it evolved in the years since then?
Well, it's been around a while now. You know, I've been working on it since its launch, and I'm afraid and embarrassed to say now it's considered a legacy connector. I know. It's been nearly 10 years. 10 years this CES is when it first launched with a couple of products. And it has evolved, as we all know, through multiple versions to the current version of 1.4b to accommodate the needs of the market and do all sorts of neat functionality and features that the market requires.
So that gets us into the question about the numbers. We most of us who are in this industry and many consumers as well are at least somewhat familiar with the fact that it started at 1.0 and then went to 1.1, 1.2. There was a 1.3 A and B, and now there's a 1.4 A and B. But I've heard you say recently that you're trying to get away from numbering. Is that correct?
So that's true. Let me kind of explain how HDMI came about and what the philosophy is, and you'll understand how version numbers as a number itself is really what we use to internally identify the version of the specification, but really has nothing to do with the functionality of a product. So HDMI is basically requires very minimal features and functionality. What it requires at a minimum, and this is a 1.0, is 2-channel digital audio, and it requires 480p digital video. That's it. Everything else is on top of that. And, of course, manufacturers look at the market and build whatever they want now. You can't find many digital TVs that just do 480p. But that's the minimum requirement. Everything else, again, is a manufacturer option to put on top of that. And those options are released in a version. So version 1.3, let's say, or version 1.4, the latest. It had 3D, audio return channel, some other options. It didn't mean that you had to implement 3D when you build something on the 1.4 specification. It meant you could. So think of it from a consumer point of view. To say a product was a 1.4 product really didn't mean anything because it didn't mean you had to build 3D or audio return channel. It meant that you could have. So we got people away from saying that a product was a 1.3 or 1.2 product because it actually was confusing and erroneous to assume any functionality with a version number. And instead, we told manufacturers, focus on the functions and the features themselves. So we came up with audio return channel. If you offer this, call it audio return channel, list it as audio return channel. You look for a source that has it and a TV that has it, you know that they're going to work together. 1.4 doesn't necessarily mean audio return channel. It means the possibility it has it. So that's why we've gotten away from version numbers as a way of communicating functionality.
Now, Dr. T is asking in the chat room, well, if all of these are optional, does that mean HDMI 1.0 could do 3D, for example?
Well, it depends on what you mean. 1.0, the specification doesn't have anything to do with 3D. It isn't in there. So let's talk about let's say a chip, a transmitter chip or a receiver chip based on a 1.0 specification. No, it can't. It doesn't have the bandwidth to support 3D, for example. It doesn't have the format kind of information that needs to be packed in there. So no, a lot of these older chips that were built around the 1.0 or 1.1 specification can't accommodate the new functionality, mainly because they're just not as powerful. They don't certainly have the software or firmware that they need, but they also just don't have the hardware throughput to do some of the new stuff.
The bandwidth, the actual amount of bits that you can push through the thing at in any given time frame.
That's correct. That's correct. And of course, 3D is going to require that. 4K requires bandwidth.
Right, of course. Calgary Guru in the chat room is asking or is commenting that I have a HDMI version 1.2 cable that no longer works with my latest PVR. And so he's claiming it is important to know. Now, I resist or question the application of a version number being applied to a cable, don't you?
Well, I do. That's actually where it's becomes very confusing. So in that example, let's say a cable was manufactured under the 1.2 specification. That's back when there was no high-speed cable. So what we've done is basically say you have two kinds of cables, standard or high speed. Anything pre 1.3 would have been a standard, and that means it's only been tested to not even do 1080p. It doesn't mean it can't do 1080p, but it's not been tested. So now we ask anybody who wants to buy a cable to do anything HDMI can do, look for a high-speed cable. It's got the top ceiling bandwidth, and that'll accommodate any feature that you've got out there.
Mm-hmm. Why would you suppose that an older HDMI cable wouldn't work with the latest PVR? Probably because the cable hasn't been tested to that bandwidth and probably can't carry that bandwidth.
That's exactly right. It was tested to essentially a 1080i bandwidth at 60 hertz. Some of those old cables may work, but some of them may not. They were never tested to do 1080p, for example.
Mm-hmm. And so how does a cable, you may not know this, but I'm curious, how a cable can carry more bandwidth than another cable, for example? Thicker copper or?
It's all in the manufacturing, and absolutely, it's in the gauge of copper. It's in the way it's shielded. It gets to the engineering and manufacturing capability of the manufacturer. So it's not only how much bandwidth, but how far they can take that bandwidth. So a cheaper manufacturer might be able to do a 1080p, or maybe a cable that could do twice 1080p, which is kind of the bandwidth of HDMI. If you wanted to do 3D 1080p, you could. Someone may be able to do it at 10 feet, but can't get beyond that. And others in manufacturing can get up to 30 or 40 feet on a passive cable. That's all based on the materials used and the engineering involved.
Mm-hmm. Web3965 in the chat room is asking why mini HDMI does not work with regular HDMI. I thought it did.
It should. It does. There's actually three sizes of connectors. There's the standard connector, which we see on most all TVs or Blu-ray players. Then there was the mini, which was introduced, and in 1.4 we introduced a micro. So there's actually two small form factors. They are essentially the same. They have the same tolerances and the same functionality that the larger connectors can. They are only intended to be used on smaller products like a cell phone or a digital camcorder, digital camera, but they are obviously intended to be connected to a TV in most cases. So these connectors should be absolutely interoperable. They're designed to be that way. So I'm not sure what's happening in that case.
Mm-hmm. Beatmaster is asking, is the wiring inside the cable in any way related to the HDMI version?
The wiring is not related to the HDMI version. The only exception I can think of is, as I said, we have a standard and high speed. The wiring actually is exactly the same for those. It really just is how they're tested. They're tested to be able to pass higher bandwidth, and that's manufacturing. And then the only wrinkle we have is we introduced with 1.4 the Ethernet channel. That is different wiring. And that then, if you look for a cable that uses the Ethernet channel, you can get a standard with Ethernet or a high speed with Ethernet. So the Ethernet variable as a feature has a separate channel that carries Ethernet data. That is a different wiring.
Mm-hmm. So Wisdom in the chat room is asking the same question. What about HDMI 1.1 cables carrying 3D? The answer is yes, it can if it's capable of conveying enough bandwidth for 3D.
So that's correct. If you're asking about wiring from that point of view, they're exactly the same. It's just a matter of whether they can carry the bandwidth.
Right, exactly. Now, the bandwidth of the current version of HDMI 1.4 and also 1.3, if I'm not mistaken, is 10.2 gigabits per second.
That's correct.
And what was the bandwidth, the maximum bandwidth of previous versions?
Half that. Call it 5 gigabits per second.
Okay. Now, some companies like Monster, for example, label their cables with a speed, and I'm curious. I'm just curious to know why they, and some of them aren't 10.2. They're like 6 point something. And even some HDMI switches I've seen have been in the 6.75 gigabits range. Why wouldn't they build devices that could just carry the full bandwidth? I guess it's more expensive.
Well, I can't comment on individual companies' kind of marketing plans. A lot of these times, I think these companies are out there to differentiate their own products. From our point of view, there really are two speeds that are reflected in those two speeds of cables. There's the standard speed, which is 5.1 gigabits per second, and there's the high speed, which is 10.2. When we test cables, we test at 10.2 gigabits. When we test switches that say they can do they can adhere to the 1.3 or 1.4 specification. They're all tested at the highest speeds. So the differentiation is more, I think, a way of differentiating their product and having a product line rather than necessarily adhering to the way we test in terms of compliance with the specification. Right.
A lot of people in the chat room are expressing some confusion over, well, then we do need version numbers. But really, I think what you're saying, and correct me if I'm wrong, that what you really need to know, if the manufacturer will tell you, is what is the bandwidth that the cable is capable of carrying. If you know that, it doesn't matter what version number it's labeled with.
So if we're talking cables, we have a high-speed cable, which is really, I'd probably say 95, if not even 100% of the cables in the U.S. market. You may see some in some of the other areas of the world, but 95% are high-speed cables. Those cables, with the exception of Ethernet, and if you want to get a high speed with Ethernet, you can get that too, those cables can do anything that HDMI products now offer. 3D, audio return channel, deep color, I don't care what features they have. The high-speed cable, which you can buy very inexpensively now, can handle all of that.
Well, that brings up the next question, which is, I know we can buy cheap HDMI cables. I mean, they're on Amazon for a couple bucks. Monoprice has them for $5 or $10, or you can spend hundreds. What advantage do you get as you spend more and more and more money on HDMI cables?
So that's another question that's difficult to answer because we are a licensing organization. We really don't get into the anything related to pricing or the kind of the market and what people end up selling their products for. But I will tell you this: from HDMI licensing point of view, all we care about in terms of a cable, let's say a high-speed cable, is that it complies with the specification. Whatever the adopter, we call them adopters, our licensees, whatever they want to end up doing on top of that, they can do that. But an HDMI cable is tested to make sure that the mechanical and electrical functionality works as it's supposed to, that it can pass 10.2 gigabits of data through this thing, that all the wires are attached so you have CEC and everything can work. And after that, anybody can sell it for whatever they want. I can tell you that most likely, I can't say it definitively, but most likely a $2 cable on Amazon is not going to have gone through the compliance testing to ensure that it can do everything you want it to do. Doesn't mean it won't work, but it means it's not been tested. I pulled a cable off of a retailer just the other day with a very inexpensive cable at a retailer that prides itself on low-end products. And I tested this product, and I saw that it could pass 1080p data, no problem. It could pass 10.2 gigabits per second, but they had saved money by taking the CEC wire out. So when you plugged it in, you could see things would work, but your CEC would never function. That pin was basically taken out to save, I don't know how much, a fraction of a penny on the copper that it takes to wire that thing. But that's what. So it's buyer beware. If you know the source is a good source, a good retailer, a good supplier, someone you trust, then the price can be quite different, but that's based on whatever they're adding on to it. And that's your own judgment as to whether you want that kind of level of quality, maybe in terms of manufacturing, endurance, how long it's going to last. But in terms of minimal compliance with our specification, doing what it needs to do, that's all we ask for.
Mm-hmm. And is there any way to tell, buying one cable versus another, that it has gone through compliance testing?
Well, the HDMI logo can only be used, in fact, the HDMI word can only be used and associated with products that have gone through compliance testing. Now, that's not to say that every cable out there that has an HDMI logo on it has gone through compliance testing, but that's our job at the licensing agent to continually enforce the market and go to the retailers and go online and test these things and then alert the manufacturers that they can't do what they're doing. So there's no good way, especially on cables. It's really not an issue with TVs or AVRs or the kind of mainstream hardware products. But cables are very easy to manufacture, so it's probably our biggest challenge, and we're out there doing it. But for the buyer, all I can say is, for the most part, those that use a logo are compliant. Or if it's just too cheap to be true, then use common sense. It doesn't mean it has to cost $50 or $100 to buy an HDMI cable, but if you're spending $2, you may be getting $2 worth, and so I'd be a little wary.
Understood. Well, you mentioned compliance testing, and I assume that it costs something for a manufacturer to get their products tested. And that would lead to somewhat higher prices, obviously. What do they have to end up spending?
So testing costs different. We have about 12, I think, labs worldwide that do testing, and it depends on the product type. A cable is probably the simplest, and an AVR, which has maybe many ins and many outs, is probably the more complex. I think the cost can range from $5,000 up to $15,000, depending on the complexity of the product. But the other thing is that once an adopter, once our licensees has gotten testing to a point where they understand it, then they can start doing self-testing. Still have to do the same level of rigor, but they can do it in their own kind of internal labs. We accept that. So the cost goes down the more you become, let's say, efficient and effective and knowledgeable about how to test these HDMI products.
Of course, you also need the equipment to test them. I assume that ain't cheap.
I can assure you that's not cheap. Yes, you're right. It's very, this is complex stuff, and it's very expensive. There's no question. Some of these testing benches are very expensive.
Now, I got a great question in the chat room here. How much are you involved with wireless HDMI, or are you?
So, I'm huffing and puffing now because this is a sore point for us.
A sensitive area. I've touched a nerve.
I'll give you very clear bodily cues that they're sensitive areas. To be very strict, there is nothing called wireless HDMI, and what I mean by that, in fact, it's something that we'll ask someone to stop using, because it essentially says there's an HDMI approved wireless transmission of HD content, let's say. And there is no HDMI approved wireless protocol. What there are many different wireless providers out there who, not unlike a converter cable that goes to Cat5 or a converter cable that may go to optical, we consider these nothing more than a converter cable where there is no cable. It goes from HDMI to whatever proprietary wireless protocol back to HDMI, and we test those just as we would a Cat5, from HDMI to HDMI to make sure the data that's sent is sent and received is received, and whatever happens in between we don't care about. So there is no official wireless HDMI. There are many companies who have, let's say, wireless distribution of HD content using the HDMI ports on your source and your TV, but nothing official.
Okay, very good.
So you will see, I'll just go a little bit farther, you will see out in the market some high-definition guys doing this, some people like WiGig or Wireless HD. They're really trying to do an uncompressed wireless transmission. They're in the 60 gigahertz range. It's pretty rocket science, and it's pretty cool technology. And then you get the guys like WHDI, which is more in the 5 gigahertz range, who can go through walls where the other stuff is so high bandwidth it can only be point-to-point. And then you've also got the guys in the Wi-Fi range who are using prevalent technology, but they need to highly compress and can't do the kind of bandwidth that many associate with the highest quality HD content. So where that'll all end up, they all use HDMI as their in and their out. Where that ends up is really going to be a market decision.
Yeah. So I'd like to sort of get an overview. We've been talking a lot about cables, but there are certainly other types of devices, obviously, that use HDMI. There are TVs, there are AV receivers, Blu-ray players, cable boxes, satellite receivers. I assume you have some sort of organization of where you put these devices into one category or another.
Well, you kind of went through many of the major categories. There's some you missed, but you didn't try to be, all inclusive there. But there really are. They are high level into 4 categories. A source device. So a source device is wherever is going to be transmitting. That could be a cell phone, it could be a game console, it could be a DVD player, a Blu-ray player, it could be a PVR, it could be a set-top box, but it's where the source is. Then on the end, you've got whatever's displaying that. Typically a TV, could be a projector, but essentially those are the we call them the sinks because they're the end product of where the final display is happening. Then you have a cable, broad category to connect these guys, and then you've got this other category called the repeaters, which is anything in the middle. Anything between a source and a sink we call a repeater. That's an AVR. You said it could be a sound bar. It could be a switch. It could be just a strict booster, a repeater device. So those are our 4 categories of products.
And in the category of repeater, this brings up the question of cable length. You were mentioning earlier that, perhaps a cheaper cable might carry things fine for 10 feet, but not beyond that. And whereas a more robust cable might go as much as 30 or 40 feet, you can't really know until you try it. But if you need to go much longer than that, you've either got to have a repeater or you've got to convert the signal from the HDMI cable into something that'll run very long lengths like fiber optic or Cat5. What, if anything, do you have to do with that sort of process?
So like the wireless question, when it comes to converting into other kind of protocols, there are many people who provide different ways of doing it, their own technologies. And once again, we're less concerned about what goes on in between. What we test is the HDMI portion, which is the output and the input to make sure it works. But as you said, there are many people who are meeting the market need by looking at Cat5 and Cat6 baluns, looking at a fiber optic, looking at wireless, looking at coax, anything in between to be able to extend the length of the signal. Or you can use these active cables that essentially have the kind of booster and extender built into them, or you can buy repeater boxes. So there are multiple ways of doing it, and they're all trying to do one thing, which is how can we get this very high bandwidth signal farther than we can on a passive cable, because we're running up against the laws of physics there, and copper can only do so much so far with an HDMI cable.
Right, exactly right. I was pleased to find at the CEDIA show. Did you go to the CEDIA show this year?
I did not, but we had some people there.
Mm-hmm. One of the things that was introduced that I thought was pretty interesting was from Monster Cable. They introduced an HDMI cable with an amplifier or a booster built into the cable itself, which means, so it's not a passive cable anymore, it's an active cable. And it can run quite a bit farther than than traditional passive cables. The other cool thing about it was that at the receiving end, it had a little tiny LEDs that indicated what kind of resolution you were getting, whether it was 480p or 1080p or 3D. And so I thought that was great. I assume you worked with Monster on that particular project.
Yeah, we have a lot of folks who are building active cables, and they're doing exactly that. They're trying to make a HDMI cable that can go from one end to the other uninterrupted, go as far as it can. And what they do is they've got to have electronic, circuitry in there to essentially, at some point within this, take a weakened signal and then reboost it, reconstitute it as its original signal, and then send it on its way. So they're cool technology that can really that can take the HDMI signal a lot farther than you can just with a passive cable.
Mm-hmm. Trout in the chat room is asking, when is it better to use HDMI for audio instead of other digital audio connections?
Well, I would say that the time when HDMI can provide better audio is when you want to use the high bitrate audio formats. If you've got source and your receiver, your sound system is capable of it, to be able to use the Dolby True HD or the Master Audio, DTS's format. These lossless formats use bandwidth beyond what a SPDIF can do. Or a Toslink can do. So those are where HDMI can actually be beneficial. Otherwise, I think most of the bandwidths of the audio formats can be accommodated by other cables. HDMI just does it all in one, so you've got cable consolidation as a benefit, but it won't give you anything more other than the lossless formats.
Mm-hmm. Mm-hmm. Web 3258 in the chat room is asking, are devices like the Crestron 64x64 matrix switcher, which is a heavy-duty piece of equipment, not for casual use, are those HDMI-approved products or certified, I should say? Which gets me also to another question about switchers in general. But first of all, let's answer this question.
So I can't speak to that specific product. I imagine it is. If it's got an in and an out that's HDMI, let alone 64 of them. It's it will be an HDMI compliant product. Crestron's one of our adopters, and obviously Crestron's in the business of providing kind of high quality products, and obviously commercial grade in some respects, and some high powered stuff. So I assume, I can't say for 100% sure, but I assume that's a compliant product.
Right. Rusty Bones is asking a similar question, what I was going to ask as well, which is, what about HDMI switchers? Do they need to be high-speed certified? And I asked you before we went actually on the air about if you have a switcher that has more than one output, like a matrix switcher, or, for example, a device that takes in an HDMI signal and sends it out to more than one display. What happens when those two displays are different, particularly when they have different resolutions? They're both going to send back information called EDID, Extended Display Identification, that tells the sender what their characteristics are. And if they're different, how does that get resolved?
So two questions. I'll answer Rusty's first. Switches don't have to be high speed, because high speed essentially is 10.2 gigabits per second. And in the last, well, maybe only recently have we seen that on the market. You can build a switch that does less than that and still send it on the market, sell it on the market. But I get away from cable speeds when I talk about hardware, because a switch really has to be able to operate at 1080p if that's what you want to do, or it has to operate at 1080p with 10-bit color, so it's 6 point whatever it is gigabits per second. Or if you're going to do a true kind of 1080p dual right-left 3D experience, it has to operate at 10.2 gigabits per second. But the point is that you'll buy a switch that has enough bandwidth to accommodate whatever resolution you're running. So if you're going to buy a switch that runs 1080p throughout a house, it's just got to be capable of 1080p, and it'll be tested to make sure it meets those requirements. Scott, to answer your question, it's true that in this digital world, the HDMI is not just a one-way directional. It's bidirectional. There's communication going both ways. It's certainly the bandwidth of 10.2 gigabits is all going downstream from the source to the display through the receiver. But there is information coming back at all times. And as you said, this EDID essentially is considered a profile of what the TV can do. And the TV constantly sends that information back to the source because it says, look, I can only do 1080i, so don't send me 1080p. I won't know what to do with it. Send me 1080i. And the source says, okay, I see it, and I'll send you it in a way that you can accept it. Well, if you've got two TVs, one's, let's say, a 1080i capable, one's a 1080p, coming through a single switch, how does that switch negotiate the EDID information? Well, in poorly implemented, and this is something that switches can do, but in poorly implemented switches, what it'll do is say, I got a 1080p and a 1080i. I'm going to assume 1080, the lowest resolution, send that on, and the source then sends one resolution to both displays, and you've got a 1080i signal, even though you've got a 1080p TV. So that's what some switches may do, but they're implementing it poorly, or they're implementing it, let's say, in for a lower part of the market. But there are switches that have really the ability to have independent kind of configuration, send that information to the display, the switch then to take that and say, okay, I can do both, send me both, and I'll or send me 1080p typically, and then I'll downres one to 1080i and send the 1080p on to the one that can accept it. So that's really an implementation issue, a product differentiation issue, and probably a cost issue where switches can do that, but you got to buy the right switch.
Right. So again, once again, caveat emptor, buyers should do their research and figure out if they are going to do that and they have a lower res display and a higher res display, they really want to look for a switch that will send separate signals appropriate to each display as a matter of course, rather than just down-resing everything to the lowest common denominator.
Absolutely right.
Yeah, okay. Cool. Well, we got more questions in the chat room, and I got a few more myself. But before we continue, I'd like to take a moment to thank our sponsor for this episode, which is Netflix. Now, Netflix, of course, as most of you already know, it gives you the opportunity to stream thousands of TV episodes and movies directly to your TV or your computer or your smartphone or your tablet. Just about any consumer electronics device made these days can stream Netflix. There's a Netflix app on them, and you can stream them from just about anywhere onto just about any display device, possibly using even HDMI cabling. And you can even start on one device and then say you're getting tired and you want to go to bed, but you want to finish the show. You can start it up again and continue where you left off in the next room on another system. So it's very simple and it's unlimited. You can get as much content as you can possibly consume for one low monthly subscription fee. Now, for those few of you who do not have Netflix, you can give it a 30-day free trial. Just go to netflix.com/twit and be sure to use that URL, netflix.com/twit. And we thank Netflix very much for their support of Home Theater Geeks and the entire TWiT network. So Steve Venuti, the president of HDMI Licensing, is on with us today, and we're talking about, of course, HDMI. Soundwave in the chat room asks, is there a testing procedure for HDMI adapters, like, for example, the iPhone HDMI adapter? You go down to that level?
I'm huffing and puffing to give you a signal. It's another sensitive area.
Oh, sorry about that.
Oh, it's fine. These are the critical areas. So there is no current compliance testing for those adapters. What we do require is that, let's imagine an iPhone, well, since that was the example. An iPhone
Sure.
Is outputting whatever it is, but an iPhone does not have an HDMI connector. And then you're plugging in an Apple proprietary connector to what then comes out as an HDMI receptacle. And then you can plug in your HDMI cable there and you're connected. What we do require is that source and that adapter be tested as one unit, because then we can test it as essentially a source device. It's sending out a signal. We don't care that the fact that it takes two products to kind of put those together. What we do care is that together they can send out an HDMI signal. And so we test that. that becomes compliant and so forth. Now, the problem comes when, and it's not so much of a problem with Apple because they have a very closed system, and so you can assure that the quality is going to be there. But in other systems, the problem is, what if I take this adapter that wasn't tested with this, imagine a cell phone, for example, and I use it on a different cell phone? Will it work? Well, the answer is it probably will, but it's never been tested in that configuration before. So the answer is we don't have a testing compliance suite for the adapter itself as an individual product. We always test it with a specific product, and they're supposed to sell those as a bundle because then you can be assured it's going to work. The market, they don't always do that, but we are looking at that as something that we need to add to our testing suite.
Mm-hmm. Another question in here that I can't find at the moment. Oh, here it is from Kaikev. What is the purpose or benefit of HDMI plus Ethernet or Ethernet over HDMI?
So the benefit is that you can have these devices talk to each other with a much faster bus, let's say, than anything that exists on HDMI. So if you have products that have built in this Ethernet channel, they could have high-speed graphical interfaces swapping from one to the other. They can have content go from one to the other. Now, I say that, but that's all hypothetical. The reality is we've seen very few devices that have used that feature and implemented anything over Ethernet. We think we've seen some kind of disk drives, or I should say more storage devices, consumer electronics storage devices that have used that as almost slave drives. But for the most part, we don't see any mainstream adoption of that feature on TVs and Blu-rays or AVRs. Not yet.
I mean, all the TVs and AVRs and Blu-ray players all have Ethernet ports on them as well. I suppose that doing it through HDMI would eliminate one cable.
It eliminates one cable, so you're right. But until you've got kind of prevalence of these of Ethernet implemented, I think they'll stick with the RJ45 for a while, since it's pretty cheap to implement that, and most devices have that. So we'll see if the market adopts and chooses to get rid of a cable. It may or may not. We don't know.
Leo Laporte on his radio show last Saturday, I told him that you were going to be on Home Theater Geeks, and he said, "Oh, I'd love to ask him about all the problems that people who connect things with HDMI have, and I think it's more in the past than in the present." And this is another thing you and I talked about a bit offline, and I'd love for you to talk about it here, where I know a lot of installers who, in the early days of HDMI, were just grinding their teeth, gnashing their teeth over the problems, the connection problems, and this didn't work or that didn't work with HDMI, and so they ended up just using component. And I think you've heard some of these stories yourself. How has HDMI solved these problems?
Yeah, these stories do kind of have a way of making themselves known to me. So I'll give you my perspective on this. There is no question that in the early days of HDMI, there were some interoperability issues. For the most part, they were based on the content protection that is not part of HDMI, but is essentially implemented on just about all products that have any kind of Hollywood or protected content. That's HDCP. HDCP is, because it's content protection, it requires a lot of authentication. That authentication takes time. That's why you used to see a lot more time when you switch from one channel to another. It has to go through that whole authentication. And in the early days, we had no good way of testing that HDCP portion. So there were a lot of issues, especially with repeaters, so AVRs, that had a real tough job because they're sitting in between the content provider and the display, so they had to negotiate all this stuff. And I will tell you that it was we had our growing pains. That's one issue. The second issue was that this was new technology, and even some of the smartest guys who were building this into their TVs and their DVDs back then, they had a learning curve they had to go had to grow with, and as well we did too. So the early days, we heard a lot of complaints from installers, and mostly installers because the installer was the one who's really taxing this and taking this to the extreme. The end user who's just kind of hooking up with a 6-foot cable had very few of these problems because there was just very few places to go wrong. But the installers is routing this stuff all around a house. It's going long distances. They really taking this to the limit in terms of the technical capabilities of what they were installing. So the installers still have issues with HDMI because it is still new technology. It's uncompressed video, which is very difficult to manage and very difficult to switch. So these matrix switchers, you gotta be careful and buy ones that have put the technology in to be able to do it. It's no longer as easy as component, and whether that's good or bad, it's here to stay. And analog is a lot easier to manage and a lot easier to route than digital video. It doesn't matter whether it's HDMI; it could be anything, but digital video has its own issues with it. As well, one of the biggest issues in the early days, and I think any installer will know this, was the set-top box. And the reason was we had a very difficult time. We worked it out. Again, it was a growing pain. But set-top boxes, you can imagine, would be compliant. Everything would be working fine. But any time there was a firmware upgrade, which these service providers would do on an ongoing basis, a lot of times it knocked something wrong, and we had an issue with the HDMI port. And so that's why you saw installers running component in parallel. And quite frankly, I didn't blame them in the early days. But all this stuff's getting worked out. It doesn't mean it's not difficult. It's new technology. I used to tell people at CEDIA that it will not be without growing pains and without learning how to do an installation in a digital world. It's not the same as analog. Troubleshooting and diagnostics in a digital system is so much different than an analog world. So there's opportunity here for an installer who can learn and get up to speed, but it doesn't come without its growing pains, no question.
Yeah, understood. You mentioned HDCP, and when you were talking about it, it seemed to me like the HDMI licensing doesn't really have much to do with that, other than carry it along the cable and in the devices. Is that correct?
So that's correct. HDCP technology was developed by Intel. In the HDMI specification, all we say is that if you want to protect your content, then HDCP is one that you can use. And that's it. Otherwise, it's a separate licensing organization and separate technology. We have nothing to do with the development. And by the way, an interesting point of fact, no product is required to carry HDCP. Nowhere in our spec does it say you must carry it. That's a completely market-driven decision. The reality is there's no TV that doesn't carry it because you've got to be able to accommodate for it. No EVR doesn't also carry it. But of course, a digital camera probably does not need to carry it or have it built in. A digital camcorder or a digital camera or a cell phone may not have to carry it. But for the most part, the mainstream products that could ever be capable of showing any protected content out of Hollywood would inevitably carry it.
A bunch of people in the chat room are mentioning there's no real point to it because it's already been broken. Pirates can hack it, no problem. So what's the point? Now that's not really a question you can address officially anyway. Personally, what do you think?
Okay, unofficially. So you're right. It has been cracked. It was cracked a couple years ago, maybe a year and a half ago. But that doesn't mean that it's very easy to access this content. This content, even if you crack HDCP, to have a system that can somehow accommodate this, let's say 1080p content, 5 gigabits per second, and to have a disk array that can handle that is very difficult. It's not as easy as hacking this thing. It's also having the systems to be able to copy this stuff. So it's not as if content is being copied readily. This is not something that's easy to do, whether or not you have the code. The other thing I would say is that this hasn't gone by the wayside in terms of Hollywood, and Intel has released HDCP 2.0, which currently is not implemented on anything HDMI, but I'm assuming that will be something that might be we might see in the future. And HDMI 2.0 is exactly in response to the hacking of 1.2, I think, was the latest HDCP version, and so you'll see stronger content available for, I don't know, I have to ask Hollywood, but maybe 4K content will be protected that way, or maybe earlier release. I don't know, but I do know that they're working on the whole, and they came up with a whole new content protection scheme. Have no idea when it'll be released.
Okay. Well, speaking of the future, we have a few minutes left, and I'd like to ask you about the future of HDMI. What can we expect to see in the next iteration, be it numbered or not?
Well, I will tell you that I'll tell you what's been publicly announced, since they keep a gag on us, and to be able to say anything other than what has been publicly announced. First of all, from an organizational point of view, it might not be that interesting to the audience, but it's you may see it in the news. The HDMI specification was the work of 7 companies that founded this, and that's Sony, Panasonic, Hitachi, Toshiba, Philips, Technicolor, and Silicon Image. Those were the 7 companies. They were the 7 companies that got together. Their technical people developed the specification up to the release of 1.4b, which has been out in the market now for several years. The 7 companies have now said, this HDMI is bigger than the 7 of us, and it's being used in ways that we as 7 companies don't really have the expertise to determine. We want to open the development of the specification to a larger group of companies. So what they did was to announce a new organization. It was announced about a year ago, called the HDMI Forum. And now that's the body that develops the specification, an open organization, open to anyone. You got to pay some money, but it has now 80 members, and that's the group that now is developing the specification. So I'll tell you what the forum has said. My HDMI Licensing is not the agent for the forum, so I don't have any official capacity with the forum, except I am the chair of the technical working group. But the forum has said at last CES they expect to announce a new spec at the end of 2012. That's their target date for release of a new specification. And although they kind of mentioned a lot of little features that may be in and out of this thing, they basically said the focus of that new specification will accommodate higher resolutions. So by higher resolutions, what they mean is 4K 60.
Now, HDMI, the current version, which I will still call 1.4 just for easy reference, can do 4K, but only at 24 frames a second, or maybe 30 as well, or maybe just 24. I don't remember. 24,
25 for the Europe audience, and then 30.
Ah, okay. So the new specification will allow 4K at 60 frames per second.
That's correct. So essentially doubling the bandwidth.
So now we're at 20.4 gigabits per second.
Yeah, I can't be exactly sure of the number, but essentially in that ballpark. Roughly, yes.
Yeah, okay. What about the other connection schemes that have popped up? For example, HD-Base-T, which combines HDMI with Ethernet, which HDMI already has, but a bunch of other stuff as well, even power in some cases, or DisplayPort. Does your organization have anything to do with those connections at all, or are they competing, or what's the deal?
So one's complementary and one's competing. HD-Base-T is essentially, as you say, has a bunch of features and functionalities specifically designed for the installer market. That it layers on top of HDMI. So the guys who are behind that, Valens Semiconductor, is an HDMI adopter, and I know them well. And so what they do is they say, all right, HDMI in and of itself is fine for connecting a DVD to a TV, but the installer wants some more kind of control and command and maybe power, as you say, and an assured way of going a long distance. So they built that on top of HDMI to offer to essentially the installer community. That's a complementary on top of HDMI. Think of it as incremental to HDMI. DisplayPort is essentially a competitor to HDMI. It's another uncompressed digital video interface. It was launched about 3 years after HDMI. DisplayPort, in my mind, is a PC-centric interface. So it tries to be a CE interface, and they certainly want to be, but they have become an interface that PCs are using, essentially a VGA replacement. So even in the PC world, you see a lot of HDMI on those PCs that I think could connect to a TV. On other PCs that are in a B2B market that may want to connect to a digital display, they may use DisplayPort.
Very good. Well, we've come to the end of a fascinating hour with Steve Venuti, the president of HDMI Licensing, and I've certainly learned a lot more about HDMI than I knew before, and I hope everyone listening did as well. Thanks so much, Steve.
Thank you, Scott.
So if you want to learn yet more about HDMI, you can go to hdmi.org, which is the HDMI licensing website, and there's plenty of information there. You can also email me at scott@twit.tv with questions or comments, suggestions for future guests on the podcast. I am eager to read what you have to say. Next week, my guest geek is scheduled to be none other than Noel Lee, the founder and head monster of Monster Cable. So there's going to be quite a lively discussion there, I am sure. And I hope you will join me for that. It should be fascinating. Until then, geek out.